Okay, welcome Epistats. This is section 2 of chapter 3, which is now unit 2 in the new College Board syllabus. So we are looking at least square regression lines. In the previous unit, we talked about scatter plots and correlation coefficient. So let's go ahead and just briefly look at what this entails. So this is what you expect to learn. Of course, feel free to pause the video at any moment should you want to confirm something. So we'll be looking at a regression line to mean a line of best fit. If you have these dots plotted on a graph and then you want to see which line kind of fits to balance the dots above and below it, then that line is called the line of best fit. There could be several of them, so in AP statistics, we're only going to deal with one, which is called least square regression line. The equation of the least square regression line is y hat is equals to mx plus b. Just thinking about equation of a straight line, this is the same. So m here represents the slope, and then b will be the y-intercept. And you can always use that equation from you can get it from the calculator and do a lot of stuff with it. The only thing you need to remember is when you're writing the equation, you have to define what y hat is and also what x represents. You'll be graded wrong if you do not define that. So you have an option of either writing it in terms of y hat or replacing predicted backpacks in that position. Now, the most important thing in this section is to know how to interpret whatever you're getting. So if I look at the first thing is the y-intercept, which is where the line is predicted to cut the y-axis. So we know that on that line, the value of x is always 0. So for this question, you'll say a student weighing 0 pounds is predicted to have a backpack weight of 16.3. So you look at the y-axis and where the linear regression line would intersect it, and that is the point you're trying to interpret. Make sure you try to write in the same way as stated here, because changing any of the meanings to this, then it might be interpreting a wrong thing. And mostly, in most cases, when interpreting the y-intercept, in most instances, it doesn't make sense. For example, here they say that a student weighing 0 pounds, which is somehow impossible if you think about it. What about the slope? So the slope of that regression line, of course, looking at this, you can see that it's positive. You can see that the slope is positive. So when describing the slope, just think about the wording the way it's here. So for each additional pound, and we're talking about for each addition on the x-axis, although this depends on the context, so it will not always be pounds. It could be any other type of data. But of course, they have to be quantitative in nature. So it's predicted that their backpack will weigh an additional 0.0908 pounds more on average. So the slope is obtained from the equation. That's the coefficient of x. Y hat is equals to a plus the value that is there before x, so 0.0908. I hope you can see that. So again, most important thing is to maintain the way the writings appear. So this is kind of a way of remembering how to interpret the slope. So make sure that you follow the path. That's when there's what's on the x-axis and what's on the y-axis. So I'll repeat again, this unit, very simple. What's tested more is, are you interpreting things the way they're supposed to be? Whenever you have the equation, so like I said, y hat is equal to 7x plus 270. This is not sufficient. You must define your variable. Please remember that. That's just additional questions on that. And we can always use, this is predicted y. If we have any value of x and plug in there, it can always give us the predicted y value. So once you know your predicted y value, you can always add it to the formula there. You can look at those examples by pausing the video and try and see how the interpretations are done. Now in AP, we're going to be talking about least square regression line, and the word squares, from what you can tell in algebra, you're kind of getting squares. And in statistics, we mostly square values to try and eliminate negatives. You can imagine the distance. So this is your line of best fit, which will touch some of the points and might not touch some of them. So the points that are above were kind of above the prediction. So the best fit line shows where the actual value should fall. We're going to be looking at how to find residuals now. And this is just the TI Inspire class. Again, you can post that and try the calculations. AP will expect you to calculate using the calculator. And you can see it gives you all the values, the slope, the y-intercept. This is coefficient of determination. We'll talk about that in a bit. Correlation coefficient is there. Again, this is how to go about TI Inspire to do that. Then it will give you the graph with your least square regression line there. So some of the points will be above the line, some of the points will be below the line. So to get a residual, we need to get the difference between, it's easy to remember residual, it's always AP, actual minus predicted. So in this case, I have some values above, some values below. So the actual are the dots that you can see, and then the prediction will be on the line. And if you're able to get all the values, if you look at the vertical distance above, like from the actual value to the line, and you're able to add all of them, of course, the ones above the line will be positive, the ones below the line will be negative. Think about it, if you add all those values, you're most likely to get 0, and that is why we do the square. So when you square negatives, they become positive. And we can use the formula to get the predictions just by plugging in. So this is a question that you can attempt. Then the solution is right there. Again, pause the video and try before you look at the answer. So we have something called a residual plot. And this is a graph that is still obtained by from the, once we have your scatter plot and then you have the least square regression line on it, you can use your calculator to plot a residual plot. So residual plot, remember, I told you that in a normal situation, if your line of best fit was a balancing point, then if you add the residuals above the line, and then you add the residuals below the line, the value should be very close to 0. So if you plot residuals and the x-axis values, you're going to get a residual plot. You need to look at the residual plot and see if it doesn't show any distinct pattern, because the idea behind relation and describing relationship is we want to be sure that the two variables really show a trend which is linear. So it's only the residual plot that confirms that. So when you have the residual plot, you can say that there's truly a linear relationship between those two sets of quantitative data. On the calculator, that's how you get it. So if you think about this situation, so if you look at this residual plot, and this is from where it came from, you can clearly see a curved pattern. So in this case, you say that it's not appropriate. So a linear model is not appropriate for that set of data. However, in this case, the random dots above and below on the residual plot tells you that a linear model was appropriate. So that's a very important point in this unit. We'll talk about the computer output later on, but just to recap what I've said, the most important thing is you need to know how to interpret the slope. You need to know how to interpret the y-intercept. You also need to know how to interpret r. Then we have r squared, which is coefficient of determination. So what it tells us is how much the linear scale regression line is good at predicting the values of y. And again, you must write this in this way. So if you know the percentage, for instance, 60.6% of the variation in pack weight is explained by the linear relationship with body weight. Pay attention to what's the explanatory variable and what is response variable. Sometimes I make it interesting. I just decide to say what is not explained. So, it will be 100 minus 60.6. So r squared is what is explained. If you want to get what is not explained, you can do 1 minus r squared or 100 minus r squared if it was given as a percentage. You can pause the video and look at some of the way I've tried to indicate there. And this is the formula for standard deviation of the residuals. You should also know how to interpret it. I'll do that in a different video for the computer output. Then extrapolation talks about predicting values outside the range that is given. So you should avoid that because you're not sure how that will behave. You don't know what the next point will look like. Then we also have other points that could be out of the linear regression line. So we could have an outlier, high leverage point, an influential point, and so on. You want to maybe check sometimes what's the real effect of influential points, what's the effect of a high leverage point. And this could be done using some applets that exist online. Otherwise, thank you very much for watching this. Please send me questions on the comment section.